Hey class, this is Mr. Wynn here with a video on 16.2 called Transforming Quadratic Functions. So last lesson we learned what a quadratic function is, and we did a little bit of transformations actually. When we had our a value, we did a vertical stretch and vertical compression. Just a quick review, so remember your original, your x squared, that's your parent function. If our a was greater than 1, it became a vertical stretch, kind of like this. Okay. If our a was less than 1, between 0 and 1, it became a vertical compression like this. Okay, not perfect drawing, but hopefully you get the point. If a was negative, our graph opened downward instead. Okay. If it was a negative, like negative 1/2, for example, it would still open downward, be vertical, but be a vertical compression. But if a was lower than -1, so the absolute value was greater than 1, it would be a vertical stretch again, just upside down. So if any of that seems unfamiliar to you, I would recommend you go back and review that lesson 16.1. I have a video on that. Okay. So this lesson we're going to do a little bit more transforming, meaning moving the graph and stuff. So part A here, every quadratic function can be represented by an equation of this form. So g of x is equal to a, and then in parentheses x minus h, and then that is all squared, so that the x minus h, the whole thing is squared, plus k. So the values of the parameters a, h, and k determine how the graph of the function compares to the graph of the parent function. Remember, your parent function is your original. X squared is the most basic kind of quadratic function. Use the method shown to graph this specific equation, 2 times x minus 3 squared plus 1, by transforming the graph of f of x equals x squared, the parent function. So step number 1, we're just going to graph our parent function, just the x squared. Alright, hopefully we can get familiar with this, but I know the point 0 is on there because 0 is 0 squared. 1 and 1 squared, or 1, 1 is on there. Same thing with -1 and 1. 2, my y value, if my x is 2, it's got to be 4 because 2 squared is 4. Same thing with -2. 3 goes with 9. -3 goes with 9 as well. So here's my parent function. Let's see if I can draw this well. Okay. Yeah, make sure it's not supposed to look pointy at the end, so I'm going to try my best to do that. Okay. Alright, here's my parabola. Okay, so that was the parent function. Now part B, it says to graph, stretch the graph vertically by a factor of 2 to obtain the graph of y equals 2x squared. So they got this 2 from right here in the equation. That's the a value. So if we just do, we're doing just one transformation at a time. The first one is we're doing the vertical stretch with our a value of 2. So how we do that, we take our parent function like it was before, but instead of the y value being x squared, now I'm just going to double each of those values, right, times 2. So you could fill out a table if you want to do that. That would be a good idea actually. But I have the point 1, 1 on here, so instead of 1, 1, I'm going to do 1, 2, because my y value is doubled, times 2. Same thing with -1. Instead of the point 2, 4, I'm going to double my y value, so I should have the point 2, 8, also -2, 8. And the point 3, 9, I should double the y value, so 3, 18. And -3, 18, that's going to go off the page, so I'm not going to worry about that actually. So I'll just graph this. Alright. There we go. Okay, good enough. So that's my y equals 2x squared. Notice that the point 2, 4, that's going to move, let's see, that moved to our point 2, 8. Right? That's the new point. So the point 2, 4 was originally right here, so that's going to move up like that. Maybe I'll just graph the other parent, the parent function underneath is kind of like this. Right? So the blue is my parent function, the red is my new function. Everything is stretched up, doubled, like that. Okay, that's too confusing, so I'm just going to erase that, actually. Okay, there we go. So we did that step. Next step, we want to translate the graph to the right 3 units and up 1 unit to obtain this new graph. Okay. So I'm looking at my point 0, 0. I'm going to move it to the right 3 units, and I'm going to move it up 1 unit. So 0, 0, I'm going to go to the right 3, so 1, 2, 3, I'm going to go up 1, and here we go. All right. And then I had the point 1, 2. Point 1, 2 would have been right here. So I'm going to move it to the right 3. 1, 2, 3, up 1. Here we go. So that's the new point. The point negative 1, 2 was on my graph. So 1, 2, 3, up 1. Here we go. The point 2, 8. 2, 8 is here. We're going to move it to the right 3. 1, 2, 3, up 1. There we go. Negative 2, 8. 1, 2, 3, up 1. There we go. So here is our new graph. Okay. Notice the point 2, 8. Okay. So 2, 8 is right here. It moves to the point 2 plus 3, 8 plus 1. That one moved over here. So this is the point 5, 9. Alright, and you can look through a few of these reflection questions. Okay. Actually, this first one is good. Compare the minimum values of f of x equals x squared and g of x equals 2 times x minus 3 squared plus 1. How is the minimum value related to the vertex? Our minimum value is the vertex. Okay, just some good vocab there. Alright. Yeah. Okay. Yeah, let's look at the next part. So we're going to break down what we did, or kind of understand what's happening behind the scenes. So a vertical translation of a parabola is a shift of the parabola up or down with no change in the shape of the parabola. So you should have learned about translations last year, hopefully. But we're just shifting it up or down across the graph. So the graph of the function, x squared plus k, is the graph of x squared translated vertically. If k is positive or greater than 0, the graph is going to go up. If k is negative or less than 0, the graph is going to go down. So let's look at an example. X squared plus 2. Is there a k value positive or negative? Looks like it's positive. X squared plus k, so x squared plus 2. K is 2. So what they did here is first they graphed the parent function. So just like before, 0 and 1, 1, 2, 4, 3, 9, and negative 9. Sorry, negative 3, 9. Here's my parabola. Okay, close enough. Here's my parent function. Now to graph the new function, notice I have the point 0, 0 here. Over here I have the point 0, 2. So that's going to go up 2. Over here I had the point 1, 1. Now on here I add 2 to that, so now it's 1, 3. So 1, 3. Also negative 1, 3. Okay, let's look at the 2's. So 2, 4 is going to become 2, 6. 2, 6, so my y value's moved up 2. And then 3, 9 becomes 3, 11. 3, 11, and negative 3, 11. Just like that. So all of my points are moved up 2 by adding 2 to the y value. The function has a minimum value of 2. That's because my vertex is there. The y value of that vertex is 2. It's the lowest y value my graph is ever going to be. The axis of symmetry is still x is equal to 0, like this. Okay, so again, vertical translation, adding k. So if k is positive, it's going to go up, just like this. If k is negative, it's going to go down. So do these practice problems. It's really just this, well, yeah. This one, x squared minus 5. So your parent function, go ahead and do this on your own, but your parent function will look something like that. I'm just doing it roughly. When you do minus 5, all of the points should shift down by 5 units. So your end result might look something like this. Okay. So go ahead and fill out those values, all those values, and make sure you know how to do this. Okay, and these are more good practice problems. Plus 4 means your graph should go up 4. Minus 7 means your graph should go down 7. Now we're going to look at horizontal translations. A horizontal translation is a shift left to right. So instead of up and down, we're doing just left to right. Now this is tricky, but x minus h squared is what the form looks like. So if h is positive, it's going to go to the right, and if h is negative, it's going to go to the left. But notice we have a negative here, so x minus h. So if I have, like over here, I have x minus 1, x minus h, x minus 1, so my h is actually a positive 1. Okay, so it's kind of counterintuitive, but you'll just have to get used to it. There's a reason for it, but that's going to take some time to explain. So if you're interested, you can come to tutorials. Now, it wants to graph the parent function again, so let me just do that as quick as I can. And here we go. Here's my parent function. I totally missed the last point there, but it's fine. So now I'm going to do x minus 1 squared. Alright, here they plugged in all these x values into the equation. So negative 3 minus 1 is negative 4. Square that and they got 16. And that's off my page, so that's fine. Negative 2, 9. They did all that. Here we go. Negative 1, 4. And 1, 4. 0, 1. Right here. Okay. 1, 0, and I'm doing this wrong. Yeah, I'm doing this wrong. Okay, I apologize. So, negative 3, 16 is off the page. Negative 2, 9. Negative 2, 9 is right here. Negative 1, 4. Negative 1, 4 is right there. 0, 1. 1, 0. 2, 1. And 3, 4 are the points I have on here. Okay. So this is a little bit weird, but if I actually did my x value of 4, I should have gotten this point right here. Then I have my parabola like this. So that's 4, 9. Yeah, it looks right. Okay. So notice these parabolas look almost the same, except if I took this parabola, I moved it over to the right just a little bit, I'm going to have the new one. So we would say it shifted to the right by 1 unit. Okay, h value is 1. So we graph that by plotting the points. Our minimum value is 0 again. Our axis of symmetry is now x is equal to 1. Okay, axis of symmetry goes through the vertex, cutting it in half. Alright, so that's a horizontal translation. Again, double check your h value is going to be minus h, so your h is going to be the other sign. So x minus 1, h is 1. This one you definitely need to do practice on. Like here, x plus 1. If you're looking at the h value like it showed earlier, x minus h, my h value here has to be negative 1 in order to make it x plus 1.